Welcome you all to Water Resources Engineering class. In today's lecture, we focus on the measurement of precipitation. Precipitation or rainfall we use almost in a similar way. So our today's lecture is mainly focused on the measurement of precipitation. What are the devices that we have for the measurement of precipitation? We have two types of devices. One is non-recording rain gauges. Second one is recording rain gauges. The non-recording rain gauge is the old first invention is what the Siemens rain gauge. Siemens rain gauge was the first rain gauge that has been installed to measure the precipitation. Then afterwards, the recording rain gauges have come into picture. The recording rain gauges, they record by themselves. They're all self-recording. So in that self-recording rain gauges, we have three. One is tipping bucket type. The second one is self-recording float type rain gauge. Third one is weighing bucket rain gauge. So these are the three recording rain gauges, whereas Siemens rain gauge is the non-recording rain gauge. So in this non-recording rain gauge, Indian Meteorological Department is also using the Siemens rain gauge. And at the same time, in the recording rain gauges, the float type rain gauge is used by the Indian Meteorological Department. So now let us go into the basic fundamentally what is these recording or non-recording rain gauges. The non-recording rain gauges, Siemens rain gauge, very simple, sturdy, very easy to work, and at the same time inexpensive. Cost is very low, and there is no maintenance at all. There is no maintenance, very low maintenance. Normally in the rural areas, we prefer this type of rain gauge. But what is the problem with that rain gauge? The problem with that rain gauge is we require a person. That is the problem actually. So that means every day a person has to go to the rain gauge, right? Take that, what you call it as measure the what is the rainfall and record the rainfall. So this human intervention is a must actually in the Siemens rain gauge. And again, one more problem with this is you can measure only rainfall. But you may be doubting, so sir, in what units the rainfall is measured? The rainfall is measured, the precipitation is measured in terms of depth. Please note it. The precipitation or the rainfall are measured in terms of depth, in terms of millimeters or centimeters. Then coming to the third point is we cannot measure the intensity. We cannot measure the intensity. That means, for example, there is a half an hour or 1 hour thunderstorm. So what is the intensity of that rainfall? That intensity you cannot measure by the Siemens rain gauge. So the third problem with that rain gauge is naturally when the human involvement is there, possibility of error is there. So that is third. So the problems are, these are the three problems. One is a person is required for us. He has to go and measure and record. Second thing is it cannot give intensity. Third one is the possibility of errors is more because human intervention is there. Whereas what is the plus points of it? Plus points of it is very simple, very sturdy, very easy to work, cost-wise cheap, maintenance is nothing actually. So that is why this is the advantages and these are the disadvantages. Then why you go for recording rain gauges? The recording rain gauges, tipping bucket type, weighing bucket type, float type. These are the three. And please tell me, out of the three, which is the Indian Meteorological Department has accepted and done? That is float type. Please remember once again. And coming to the recording rain gauges, number one is it is expensive. No doubt, actually, any recording rain gauge is expensive. But the advantage is what? In addition to the rainfall, it measures the rainfall intensity also. Then next one is the tipping bucket type is completely fully automated actually. In any automatic weather station, normally we use these type of recording rain gauges. So that is second thing. And even in float type also, it's an automatic thing actually. So whether it is tipping bucket type or it is weighing bucket type or it is float type, all these three are actually self-recording rain gauges. They are fully automatic actually. They are all being used in the automatic weather stations, and actually the advantage is inaccessible points. Daily we cannot go over there. There is that inaccessible points. If you want to measure the rainfall in that area, definitely recording rain gauges, we will use it. Because in the remote areas, how to go every day, that may not be possible. So we install and we connect it to basically some recording room somewhere in different place, and automatically from there we record the rainfall and the rainfall intensity. So that is one of the important thing. Coming to the first one, non-recording rain gauges. I am trying to explain you how it is, what are the steps you should take it, how you should install that rain gauge, and all those things let us see first. So in that case, the Siemens rain gauge, if I take it, I already told Indian Meteorological Department has accepted the Siemens rain gauge with a little modifications in that, and that is what we are right now. Any place in this country, entire India, the non-recording rain gauge means Siemens rain gauge. That right, it measures rainfall in terms of depth units, that is millimeters or centimeters. What it is, it's just a metal container, gentlemen, nothing else. It's just a metal container. What is how you are going to really construct this? Now you choose a land first. The land should be very flat. The open area should be very open. There should not be any obstructions nearby. So that you check it. Find out such area, a very flat area, no obstructions nearby. So no obstructions nearby, such type of area you find. There what you do is you start constructing, for example, there 60 by 60, basically 60 length, 60 width and 60 depth. Like that one concrete, basically what you call it as concrete or masonry thing you constructed in such a way that that portion is some 5.08 centimeters outside the ground level. I will show the figure also to you. Then what you should do, this Siemens rain gauge, which is a metal one, bring it, insert into it such that the dimensions, let us know the dimensions of the Siemens rain gauge also. It's nothing but actually a cylindrical metal bucket like, which is having a diameter of around, for example, that means 127 mm. That is the 12.7 centimeters. The diameter basically it will be there, and only some depth units are being given. How much? So that we will do. I will show you in this actually in this the figure also. Now you see the figure. So this concrete block is 60 centimeters by 60 centimeters by 60 centimeters. This is the concrete block. In this concrete block, actually, the second one is. If you see concrete block, then here actually we have from the ground level 5.08 centimeters, inside the ground actually 5.08. So this is the ground level actually. So afterwards, and all this is a cylindrical metal container which is having 12.7 centimeters diameter, and naturally this top portion is what we call it as the rim of the basically it's just the rim basically. So it's also just like a metal what you call it as ring. Then before that, below that, there is a funnel actually here, and this funnel is completely kept in a glass bottle. So there is a glass bottle inside, and over the glass bottle there is a funnel. The dimensions of the up to the funnel from the ground level is 20.32 centimeters, and then above the funnel we have a rim actually, and all this is being kept in a cylindrical metal case. So this is what the construction figure is extremely important, the Siemens rain gauge, and overall width actually if you take it, it is 20.32 centimeters at the bottom. So now what is the thing? I already told that it should be kept where the ground is very horizontal, and setup is normally only thing is you cannot keep it on the top of the buildings for the reason that it has the wind effect should not be there on the rain which is falling actually, because whatever the rain that falls, that is being collected. So if that is the principle, we cannot keep it at a very high level ground actually. It should be on the flat ground. That is number one. Nearby area at least 30 meters on all sides, it should be completely vacant land. For example, in cities, if it is not possible for a thing, at least you should see that the height of the obstruction, that means from the point where you are keeping this rain gauge to that at least height of the obstruction, twice the height of the obstruction. Suppose a multi-storied building has come, which is, for example, you are taking it as some 15 meters like that. So that means at least 30 meters. If the multi-storied building is of say 7 meters, then at least 14 meters on all the sides. Naturally, there should not be anything. Very important point is it says twice the height of the obstruction or 30 meters. Whatever is possible, that you need to follow. And normally what we will do, wherever this rain gauge is installed, but we keep it a fencing actually almost 5.5 meters by 5.5 meters. We keep actually a fencing there to protect this. So this is what the construction of this rain gauge actually. So inside what I mentioned, this glass bottle is nothing but actually a bottle in which when the moment rain falls into this actually, right, then to the funnel it goes inside, and in the jar naturally it will be collected in this jar. And now whatever this is collected in the jar, that tomorrow next day morning actually, so every day morning at 8:30 a.m. the person will go over there, remove this and pour that water into a measuring jar. So that measuring jar accuracy is 0.1 mm. So pour it into it and he measures what is the depth of the rainfall. So that is how again he keeps this glass bottle in the same position and continue, and next day morning like that every day morning a person will go there, personally remove the glass bottle, measure the thing, pour it into the measuring glass and measure it and then keep it, and he enters the same thing into the record actually. So now again once again I have drawn, but see the figure, this is what exactly is going to be installed in the field. There are two containers actually, the metal container 1, metal container 2, both are together locked actually. So if you open this lock, if you open this, then you can see inside actually funnel, and under the funnel actually what will be there, under the funnel actually the glass bottle is there. So remove the top, then remove the funnel, then bring out the glass jar or glass bottle outside, pour it into a measuring glass, measure it. So every day 7th morning 8:30, that should be the phenomena. That's the standard thing which we have been accepted in the entire country. See how the Siemens rain gauge is, and this is all only nothing but opening only, nothing is there inside actually. It's only for the protection of the rain gauge. So now coming to the recording rain gauges. In the recording rain gauges, I already mentioned you tipping bucket rain gauge. Tipping bucket rain gauge is used in the automatic weather stations. It is a self-recording rain gauge actually. So there is no human intervention is there. But only thing is the power connections and all are required, and similarly calibration of the instrument is also required. What is there in the inside in that actually? There is nothing actually. There will be two buckets will be there. So you can see the buckets are here. One bucket for this is first bucket, this is second bucket. I have shown you this is first bucket, this is second bucket. The same is the first bucket, second bucket. I have shown different figures actually. What will happen? Again the rain falls into the here actually, and there is a dimension for 30 mm for it, and the rain enters through the funnel actually into the bucket 1 actually. When once the bucket 1 it reaches to 0.25 mm of rainfall, naturally it tips. Tips means actually what will happen, it is now connected to a pivot. So naturally tips means it goes down. When it goes down, the second one comes and occupy its position. When it comes down, automatically this goes up and occupy its position. So that means that one tip is being recorded. One tip is equivalent to how much mm of rainfall? 0.25 mm of rainfall. And naturally, this will be connected to a drum also. So on that drum, actually, depending on the number of tips, it go on adding the rainfall. So naturally, it gives over a period of time what is the cumulative rainfall. For example, in the first 4 seconds or 3 seconds, 0.25 mm. Again, next 0.25 mm, again next 0.2. So it gives a graph actually for us. So like that, this drum is continuously rotating. On the drum, depending on the tips, actually the rainfall is being drawn actually here. So this gives directly to me the rainfall mass curve at the end, which is nothing but a graph that is plotted time versus cumulative rainfall that can be obtained. Not only that, it also gives the intensity of rainfall. How fast, that means intensity of rainfall means rainfall per hour is what we call it as the intensity of rainfall. It gives also that. Now depending on the storm actually, so number of tips, how many are taking place, each tip is 0.25 mm into number of tips is equal to total rainfall. That is the principle in this. So in this actually you should remember there are 2 buckets actually. Each bucket normally after once it reaches to 0.25 mm of rainfall, that is how it is calibrated. So when once it reaches to that, it tips actually and the tip is recorded actually. Then the second one comes into picture, again 0.25 mm it goes, and these 2 buckets are actually, these tipping buckets are only connected to a pivot through which actually they move in that direction. So this is the second one, which is the now the thing. And now the third thing is weighing bucket rain gauge. This is also a recording rain gauge. Whatever the weighing bucket type we are talking, it is also a recording rain gauge. Please note it. It is also a recording rain gauge. But it is a self-recording rain gauge. Please note that word very clearly. What is the principle in that? Same principle. Here if you can see, here I have drawn different figures to make you to understand how to draw, because now tomorrow you need to reproduce in the exam. How to reproduce it? So that's why practice this. Here also if you say take it, again a bottle is there actually. It's a metallic bottle actually. So metal cover I already mentioned. Then the receiving funnel, into this funnel the rainfall from the naturally it is received. Once it is here, it is, this is the weighing bucket. A weighing bucket is there. So in that it is connected. So under that actually we have a mechanism. This is what actually that differs from non-recording to recording. There will be a mechanism in each of the thing, and what is that exact mechanism? If you can note that, then the whole thing is over. So here actually we have a spring balance here. So this spring balance, depending on the weight of water in the container or in the catch bucket, automatically what will happen? It goes down. When it goes down, actually there will be a connection, there will be a pen actually, and there will be a rotating drum where graph sheet is attached to it. On the graph sheet, this pen will be depending on the weight, actually the pen will be moving on. So this is how it comes actually on this. So this is one. So for example, if you take it, this increase, what is the graph I have drawn? Between time versus accumulated rainfall. What is happening when once actually the rainfall, because of the weight, it is slowly moving up. At some point it is a horizontal line. What a horizontal line indicates? The horizontal line indicates that there is no rainfall, because there is no change in the weight of the bucket. When there is no change of the weight of the bucket means what? There is no rainfall. So this indicates there is no rainfall in this. This indicates no rainfall. So first term is over. No rainfall. again the second storm again it has occurred. So after that again it is a horizontal line. Wherever horizontal line is there, that indicates that there is no rainfall during that period. Next, what is this curve indicates? For example, if you take what the slope of this curve actually, any of this curve, the slope of the curve indicates the intensity of rainfall. Please remember the slope of this curve actually, the slope of this curve indicates the intensity. Please note it indicates the intensity of rainfall. So it measures the rainfall, it measures the intensity of rainfall. That is advantage. And any human being is required here? Absolutely no. It is directly a self-recording thing, and directly this drum is with us. So automatically we get rainfall, we get intensity of rainfall, both the things in this. Then third one actually, this is the one that is being used by the Indian Meteorological Station also, Meteorological Department also. This is float type rain gauge. What do you mean by that? Float type rain gauge. Please don't confuse actually. This is one is a float type rain gauge actually, right? The other one is the first one is the tipping bucket, then weighing bucket. Before that what we have talked about it is Simon's rain gauge. Simon's rain gauge is different, float type rain gauge is different. Simon's rain gauge is by the name, and this float type rain gauge also having a one component, we call it as siphon, but siphon is nowhere related to Simon. Please note it. So this is used in all the most of the weather stations. We are using this type of recording type rain gauge. What is the principle of that? Simple principle. Here you see again there is a funnel. Everything has a dimension. Please note the dimensions also. There is actually a rectangular box. At the top of it actually we have kept the funnel. Through the funnel the rainfall enters into the rectangular box. There is a float here. So the moment water falls into it, this float starts moving. Suppose now the water enters it and water fills in this. Then what will happen to this float? This float moves in the upward direction, right? Because it floats on water. When it floats on water, it goes up and up, right? So that's why if you start record, then the same thing is being recorded here on this. So that means when the float moves, here it moves. So how that is moving is this graph, right? Once it reaches, the float reaches to the top. When the float reaches to the top, what we have to do it? Now further rain comes, where is the space in that? So what is the option for you? Then the siphonic action has to begin. And once the siphonic action begins, naturally all the water that is collected inside the rectangular box is evacuated through this siphonic action. So that's why some people call it as siphon rain gauge, but don't call it as siphon rain gauge. It's a float type rain gauge, because no confusion between siphon and Simon actually. So now what will happen? The moment entire water is removed, automatically the float comes down actually and occupies this position. When it occupies this position, again the rainfall enters. So when it is coming down, this is nothing but the float movement. If you see, this is how it comes down. So this is how actually the float movement, this is being recorded. And when once it is being siphonic action, when siphonic action starts, this comes down. Once it comes down, what will happen next? Again, when the rainfall is there, what will happen to the graph? Again it moves up. So the float movement inside the rectangular box is recorded in a graph that is attached to it. This is the drum, a rotating drum on which actually this will be plotting it. So that is the next. So this is what I mentioned it as the standard one. Coming to how to compare between the rain gauges. There I have finally 4 rain gauges. One is Simon's rain gauge, tipping bucket rain gauge, then weighing bucket rain gauge, float type rain gauge. So IMD what uses what actually out of this? One is Simon's rain gauge non-recording type, whereas float type is the recording type. This one and this one are being used by IMD. But this anybody whoever wants to conduct some research work in this weighing bucket, normally people prefer it. So tipping bucket is also is being used almost majority stations. So now if I take it, how it works. So now you tell me, Simon's rain gauge is manual collection. Every day 8:30. So morning 8:30 today, and then again next day morning 8:30. So that means this completes one day. A person should be there. He has to go every day. He has to take out the glass jar. He has to pour it on a measuring glass. He has to measure it, and he has to write in the book or computer, whatever it is. He has to enter the data. Whereas the second one is, this is commonly used in all weather stations. All the government weather stations are mostly this float type rain gauge only. So here what is the thing, on the mechanical drum records the rainfall automatically, which I have shown just now to you. That means it measures the rainfall, it measures the rainfall intensity also. Most of the automated weather stations, AWS means automated weather stations, normally this digital tipping mechanism. Number of times that tips that takes place, based on that the rainfall can be calculated. That is the next one. Third is research stations, normally the weight of water is converted. Principle, if you see it, weight of water is converted into rainfall. That is the next. So data, how we will collect? This is the rainfall in mm. We will collect Simon's rain gauge. This is a continuous graph of rainfall, and this is in that when each event also has occurred, the digital time stamped data we obtain it. This is highly precise data. So these are the comparisons between that. What are the advantages of the various types of rain gauges and disadvantages? If you take it, non-recording rain gauge, I don't need to tell you, simple, sturdy, inexpensive, easy to work, low maintenance, suitable in any of the areas, especially rural areas. What are the disadvantages? A person must actually, right? Then second thing is, it gives only rainfall, not rainfall intensity. Third thing is, human intervention is there, errors are possible. Whereas coming to recording type, float type, I take it, it provides continuous record of rainfall data. It measures the intensity and duration also. How much is the duration of the storm? Continuously, how much time the rainfall is there. Then useful for flood forecasting analysis, because this is what we need if you want to forecast the floods actually. And what are the disadvantages? Very expensive, undoubtedly. Regular maintenance is required, right? So because the mechanical parts are there in that, so they may get jammed also. So unless you continuously have some maintenance thing, that naturally it may go wrong actually. So that is the second. Coming to the tipping bucket type, fully automated, completely digital, record time-stamped data. Time-stamped data means when, at what time exactly it has occurred, each storm, duration, intensity, everything. And normally the data, whatever we get actually through the computer or through the data logger, it can be directly given to any weather stations for monitoring action. Whereas the problem is, very heavy storms, it will not measure accurately. That is one of the biggest problems with this, because the tipping action, actually the more and the more the rainfall, it is not accurate actually. Second thing is, power source is a must, calibration is a must. Coming to the weighing bucket type, if you take it, very accurate, absolutely very accurate. But remember, the weight is converted into rainfall. That is the second thing. So any type of precipitation, whether it is rainfall or other forms, drizzles or anything, it takes care of that. That is thing. And mostly for research purposes, this is being used, because the reason being very expensive out of all the things. Highly expensive, that is thing. Complex, basically, that is the second thing. The setup, the weight, whatever is there, has to be converted into the rainfall. So that mechanism is a complex setup, and naturally some skilled person is required to maintain that complete instrument. So that is the problem. Actually, with this that I have completed my theory part of it. But friends, please let us recollect what we have learned in the last half an hour time, that through some questions we are some multiple choice questions are here before you, and similarly some fill in the blanks questions are before you, and similarly one sentence answer type questions are also before you. Please practice these questions and try to really what you call it as your level of understanding, you do it. Otherwise, once again go back and recheck the whole thing. Which is important in the entire thing is the figures of each of the rain gauge is very, very important. That is the first thing that you should remember. The second thing which is very, very important is the whatever the questions, if you see it, the questions covers whatever I have really shared the things with you. Please start working on that. Thank you so much. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.